As we go into the classwork practice of 6.4, we'll be using what we had in Learn. So let's look at the first item. It says use properties of logarithms to expand the following expression as much as possible. Simplify any numerical expressions that can be evaluated without a calculator. All right, so as we look at example 1, what do we have here? And we want to tease apart as much as we can. So it's going to be log base 3. Now remember, this is 9 times x to the 5th. So in expanding this is going to be 9 here, plus, now we're going to put log here, and x, but what are we going to do with that 5, which is the exponent? Well, move it in front, so this becomes 5 log of x. But let's look at this for just a moment here. Can you see that this 9, and let's just do some erasing here, wanted you to see where it goes, is 3 to the 2nd. So what will happen to this 2 here? Well, this 2 goes out in front now, and we get a 2 there. And this configuration, let's look at it carefully here, because we'll see this from time to time. What did we say this configuration was equal to? A 1. So all we're left here with is a 2. And then it's going to be 5 log base, I forgot to put that there, base 3 of x. Wow. Now as we look at example 2 here, again, this little example, the way it's laid out, helps us to see what our answer is going to look like. But there we have it. Now notice this is not 15x times this. This is something a little different. We were cautioned about this. So let's start to set it up. So it's going to be log base 5. Now notice I can actually factor out a 5 from this, and I get 3x plus 5y. And since this isn't a product in here, this is a sum, this is as far as we could go there. But notice this is a 5 to the 1st power, and we have that same configuration. What is this? Well, this is a 1, and we're taking that exponent in a sense and moving it out here. So this is 1 log 5 of 5, which is a 1. So a 1 goes there. Our log base is 5. And then what's left in the parenthesis here is 3x plus 5y. Okay. And you might have left it this way, but you didn't simplify this. So a hint in the sense of what's needed there. All right, let's go on. In example 3 now, this is the expanded view. We're asked to put it in a condensed view and simplify if we can. So it's going to be natural log. Now, since this is a plus here, this is going to be 7 times, now it's going to be x, but this 2 in front is going to be the exponent of the x, which will be squared. And then this is going to be divided here. Again, that 6 is going to come up there. And it's going to be y to the 6th power. And I would put parentheses around there, and I believe that is it. So in review, never hurts, these are going to be products, 7 times x to the 2nd. The minus indicates division, y to the 6th power. Now, another way of looking at this also over here is this would be y, and then think of this as a 1 here, a negative 1 times 6, a negative 6, and bringing it down to the denominator makes that negative 6 a positive 6. So again, just a little more background and review. Looking at number 4, here is the formula for finding pH. pH is equal to a negative log. Now, in your answer, if you ever have to write the word log, you can't just type in log. You have to put the log symbol in from the keypad that I'm sure you're familiar with at this time. So what will this be? Well, in your calculator, you're going to go negative log, and be sure to put that negative there, and then a parenthesis comes up, and you're going to put this in, 9.32 times, hit that times symbol, 10 caret, and then negative 7, and then close the parenthesis. Now give that a try and see what you get. Now you are to round off to 1 decimal place according to our instructions. So this will become 6.0, which is slightly acid, if you recall that scale. 7 being neutral, above 7 being alkaline, below 7 being acidic. Every once in a while they give us something that's a tad easy. Take a look at this and see if you could write it in its condensed form. Well, it'll be natural log. This is this times this. So in parentheses, 12, you put it alphabetically, YZ. Ooh. So again, in an expanded form, this is 12 times Y times Z. They could have separated these as well somewhat, but this is its condensed form. Now, as we look at example 6, they want us to expand this. And what can we do? And they're giving us a model to follow down here. So inspection and thought is often a good thing to look at and ponder as we look at this expression here. Well, can you see, again, these are not products. This is the sum of things. But can I factor anything out of this? So let's start. Log base 2. I can factor an 8 out of that and get x squared plus 10x plus 25. And can I get products out of this? Well, this is a perfect square trinomial, that will factor into x plus 5, the quantity squared. Okay, so we're going to get log base 2. Now 8 is actually 2 to the third power. And then now this is this times this. So this will be plus log here. And this configuration, we're going to take our 3, put it out in front, and this we said just becomes a 1. So this is going to be 3, and this is log base 2 here. And we're going to take this 2, put that out in front of the log. So that would be a 2 there, base 2. And then in our parentheses, x plus 5. Okay. Again, it looked a little daunting initially, but hopefully this is helpful. If you get one like this, that's the protocol. Now, as we look at these, I want you to keep in mind that I've done the practice already. I have worked these out. So I thought about these and I've written them out. So in a sense, you're gaining some of the strategy that I use to think through it and hopefully model how to do these. So looking at example 7 here, what do we see? Well, we know this is going to be multiplication and this is going to be division. So, and then this is an exponent, this is an exponent, and this is an exponent. So let's see what we have. Log. Now it's of x to the 4th, y to the 6th, raised to the 2nd power, times 1 over x to the 4th power. And here I'm going to, this is times this, but I can put it y to the negative 7 power. Keep in mind that that would bring it down to the denominator. And let's simplify this. Again, there's a couple of ways to do this. And I want to expand this. So this is log. We're going to use the powers rule. So this is x to the 8th, y to the 12th. Now, to get my x from the denominator up to the numerator here, I'm just going to make this 4 a negative 4. So this is now x to the negative 4. And this is going to be y to the negative 7. Again, there are different ways to do it. This is the way, after working it out, I found to be the easiest. Now, we got log. Again, it's still base 10. Now I have minus 4 and 8 will give us x to the 4th. Now y to the 12th minus 7 is going to give us y to the 5th. And that is the answer to this one. And there is the protocol to get to it. Now you could have made it a little more complicated by putting this as a fraction and things. I think this may be the easiest way. All right, in example 8, we're looking at this expression here that I've written big up here. Now, what we're asked to do is take it step by step and then write it as an expression without any logs. So right now it's in natural log form, the exponent. So this is a -3 that I'm going to bring over here as an exponent of this x. So there's x to the -3, and then there's our y. So I've just condensed this part a little bit. Now in this next step, I've taken it, and you should copy this down carefully and follow the steps. If you get one like this, this is how you do it. So I've taken this now and put it in its, since it's negative, this is going to go down to the denominator and I get this. Now I'm going to convert this from its logarithmic form, in a sense, to its exponential form, where this is base e and it's to this exponent. Now we know that this configuration here is a 1. So I'm going to take this, put it out in front as this, and then over here there'd be a 1 that I don't write, and then just condensing it a little bit more, this is the answer. Wow, lots of stuff going on there. In example 9, you're going to use your calculator skill, putting this into your calculator. So natural log, parenthesis comes up, you're going to hit the log button again. Another parenthesis comes up, put in there 388, close the parenthesis, add another parenthesis, and click enter. And you should get to 3 places, 0.951. They want you to round to 2 decimal places, so that would be 0.95. Hopefully you're able to use your calculator properly. Know your instrument. Now in example number 10, they're asking you to simplify this without using a calculator. Think of it as this. Now if you're stuck, remember, and we haven't used the change of base formula yet. Let's solve this by using change of base formula. And you could either use natural logs or the common log. It would be of this. And then using the common log of this, put this into your calculators. So it'd be log 256 divided by log, and again parentheses come up here, and the answer is 2. So again, putting this in exponential form, it's 16 to the x power equals 16 squared. Again, reviewing some older techniques that we had. Now you might have seen this. You wouldn't need a calculator if you remembered that 256 is 16 squared. All right, we're almost finished. Now, reaching into your toolkit, here we would use the change of base or change of log formula. The log, you can use natural log or regular log, of 0.239 divided by the log. Again, this is in parentheses. Now, 1/4, if you know, you could put in there 1 divided by 4 or put 0.25. And the answer is 1.032 that they want you to round to 2 decimal places, so 1.03. And you have to be familiar with the change of log formula. Now the last example we're going to do is this item 12 here. And I found that of all, this was the most challenging because they already know the decibels. When we did our flipped classroom lesson, we didn't know decibels. We just had to do this part. So this is sort of a reverse. So let's fill this in. This is going to be 137 is our decibels equals 10 log, and what we don't know here is our I. We know the I sub O is 10 to the negative 12. And now, what would our next step be? Well, we could do a little algebra here and divide this side by 10 and this side by 10. And I'm going to now rewrite it as log I over 10 to the negative 12 equals, converting this to its exponential form, which would be 10 to this power, 10 to this power. This side just becomes a 1, which is this, and this is over 1. If we kind of do cross multiplication here, this is I, and this will be this minus 12, which gives us a 1.7. 10 to the 1.7 power comes out to be this, rounded to 3 decimal places. Now, keep in mind, throughout all of these, there is a tutor bar down in the lower part of practice that if you ever get stuck, you can kind of go through that sequence. All right, well, good luck on yours and see how you do.